In this lesson, we're going to review fractions that you've been doing all through middle school. So what is a fraction? A fraction is a part of the whole. So we can take a whole and divide it into however many parts that we want. So we can divide it into 2 equal parts, 3, 4, and so on. So when we talk about a fraction, it has a numerator and a denominator. The mathematical term for a fraction is a rational number, and the only restriction we have is that the denominator cannot be 0 because we can't divide by 0. So fractions are always in the form a over b, where a is the numerator and b is the denominator. We have different types of fractions. So a proper fraction is when the numerator is smaller than the denominator. This would be a proper fraction. We can have an improper fraction where the numerator is larger than the denominator. And then we can have a mixed fraction where we have a mix of whole numbers and proper fractions. We can also talk about equivalent fractions. So equivalent fractions are equal in value, but they just have, as you notice here, different denominators. So we're dividing the same amount of space into different parts. So in the first one, we have 4 parts. We are shading 1 out of 4 parts. In the second one, we're taking that same area, but we're now dividing it into smaller units. So 8 parts, and then in the third picture we're dividing it into even smaller units, which are 16ths. So we can find equivalent fractions by multiplying or dividing the denominator and the numerator by the same ratio. So for example, I can change a denominator 4 to 8 by multiplying by 2. If I do the same to the top, that's how I get 2 over 8. And I could do the same with that one. I can multiply this by 2, do the same to the top, and that's how I get 4 over 16. So if we wanted to find 2 other fractions that are equal to 1 over 3, we can multiply numerator and denominator by the same number. Doesn't really matter which number. Let's say we decide to multiply by 2. You need to multiply numerator and denominator by the same number. So 2 over 6 is an equivalent fraction to 1 over 3. We could multiply it by 5. As long as I do the same to the top and the bottom, I will get an equivalent fraction. We can use this equivalent fractions to determine whether fractions are bigger or smaller than each other. So I want to know whether 3/5 or 2/3 is bigger. This is hard to do when the denominators are different. Not really sure. They look close to being equal, but I'm not really sure which one is bigger. So what I want to do, getting ahead of myself there, is change the denominator to the same number so that I can compare them. So I know that 5 and 3 could both be changed to 15. So if I multiply this by 3 and do the same to the top, I get 9 over 15. And then if I multiply this by 5 to get 15 and do the same to the top, I get 10 over 15. So I can see this one is a little bit bigger. Once the denominators are the same, then you can compare the numerators to see which one has the bigger value. So 10 over 15 is slightly bigger than 9 over 15. So in the same line, we could decide how you can explain whether 5 over 12 is smaller than 5 over 8 or 5 over 8 is bigger. So is 5 over 8 bigger than 5 over 12? So the numerators are the same. Some people would think that 5 over 12 is bigger because the denominator is bigger. 12 is bigger than 8, but if we change these both to a common denominator, so I know I could change them both to 24. So if I multiply 12 by 2 to get 24, do the same to the top, And then if I multiply 8 by 3 to get 24, do the same to the top, I can see that 5 over 8 is indeed bigger than 5 over 12, because if I change them to equivalent fractions, 15 over 24 is bigger than 10 over 24. Here we want to choose a value for this denominator that will make this statement true. So what number could I put on the denominator to make 2/3 bigger than that? I could put any number that's bigger than 3. Lots of answers. 2 over 3 is bigger than 2 over 5. 2 over 3 is bigger than 2 over 7. So as long as this denominator is bigger, it makes the whole fraction smaller. So if the numerators are the same, the bigger the denominator, the smaller the fraction, because you're dividing into smaller parts overall. And then two equivalent fractions to 5 over 12. Again, you could multiply the denominator by any value that you want, as long as you do the same to the numerator. So 10 over 24 would be equivalent. I could also divide. That's not going to work with the 5, so let's just stick with multiplying. So you can divide, but 5 can't be divided by any value, so we'll just stick with multiplying. So let's make it 3 times bigger. So that would be 15 over 36. So those are equivalent fractions. Okay, here we have some applications. So Mrs. Zarati eats 1/4 of the blue candies. There are 100 blue candies. How many candies did she eat in total? So we have 1/4 of the blue candies. I want to know how many would that be equal to out of 100. So what do I multiply 4 by to get 100? 25. So I'm going to find an equivalent fraction. So 1 over 4 is equivalent to how many out of 100? So it would be equal to 1. It would be equal to 25 out of 100. So therefore she eats 25 candies. So 1/4 of 100 is 25. Okay, in this application, 3 dogs are wearing purple collars. 1/4 of all the dogs are wearing purple. How many dogs are there? So similar question. 1/4 are wearing purple. We have 3, so how many in total? So if I multiply the numerator by 3, I will get an equivalent fraction. So I multiply the denominator by 3. That means that 1 over 4 is the same as 3 out of 12. Therefore, there are 12 dogs. So equivalent fractions are useful. It's kind of like doing ratios. We can find an equivalent fraction to solve a problem. Okay, when multiplying is pretty straightforward. We just multiply the numerators and the denominators together and reduce if possible. Okay, so I just multiply the two numbers in the top, 9 times 3, the two numbers in the bottom 80, and then I see if I can reduce. Is there a number that divides into 27 and 80? Nope. So this is already reduced. If you have a mixed fraction, you need to change to an improper. So how do we change 2 and 2/3 to an improper? We multiply the whole numbers by the parts. So 2 times 3 is 6, and then we add the number in the top. So 2 times 3 is 6, and then we add the 2 in the numerator. That's 8. So that's 8 over 3 times 1 over 3. Multiply the top, 8 times 1. Multiply the bottom, 3 times 9. So if you have a improper fraction, you need to change, or a mixed fraction, you need to change it to an improper. Okay, in this question it says the product of two fractions is 15 over 8. What might those two fractions be? We could pick lots of numbers. In the bottom, I just need two numbers that multiply to get 8. And in the top, I just need two numbers that multiply to get 15. So lots of options there. Okay, dividing is a little bit different than multiplying. You have to remember that dividing is like sharing. So if I had 4 over 5 divided by 2, that means that I'm sharing 4 over 5 between, let's say, 2 people. So I have 5 parts, and we have 4 of them, and I'm dividing them into 2 people. So each person, this person gets 2, and this person gets 2. So 4 over 5 divided by 2 means that each person gets 2 over 5. We could also look at it as they're getting half of what is available. So 4 over 5 divided by 2 is the same as 4 over 5 times a half. So 4 times 1 is 4, 5 times 2 is 10. And if we reduce that, we would get 2 over 5 because we could divide top and bottom by 2, and that reduces to 2 over 5. So I can see that the 4 parts out of 5, if I divide it into 2 equal parts, each one gets 2 over 5, or I can also think of it as each person getting a half of what is available. So when we divide by a fraction, we can multiply by the reciprocal to get our solution. So for example, 8 over 7 divided by 4 over 3, we can change to multiplying by the reciprocal 3 over 4. And then we just multiply the top and the bottom and reduce if possible. I see they're both even, so I'm going to divide by 2. That's 12 over 14. Again, they're even, so I could divide by 2 again. And then I have it in lowest terms. So keep reducing until you can't go any further. Any whole numbers over 1. So 3 over 5, change to multiplication, 4 over 1, the reciprocal would be 1 over 4. And then we multiply top and bottom. Cannot reduce that. There is no value that divides into 3 and 20, so we leave it. This would be 8 over 1. So 8 over 1. Change to multiplication, multiply by the reciprocal. 8 times 3 is 24, 1 times 2 is 2. That one I can divide to a whole number. Here we have 4 over 3, change division to multiplication, multiply by the reciprocal. So we have 3 times 2 on the bottom. We have 70 at the top. 0.5. Then you probably want to change it to a mixed. So how many times does 6 go into 70? It goes in 11 times. 6 times 11 is 66. I have 70. So how many do I have left? I have 4. And I could reduce 4 over 6 to 2 over 3. So putting it as a mixed is often a good option, or you could reduce it to an improper in lowest terms. Okay, if you are dividing mixed numbers, you need to change them to improper first before we do our multiplication. So I'm going to change 2 and 2/3 to 3 times 2 is 6 plus 2 is 8. So 8/3. 5 times 3 is 15 plus 2 is 17/5. So once I've done that, then I'll change division to multiplication, multiply by the reciprocal. 8 times 5 is 40. 3 times 7 is 51. And that is in lowest terms. So that's a review of dividing. Adding and subtracting, we cannot add or subtract unless we have a common denominator. So if the denominator is the same, we can just go ahead and add. So we add the numerators. 3 plus 5 is 8. 8 over 4 reduces to 2. So if the denominator is the same, we just go ahead and add or subtract the numerator. If the denominators are different, we need a common denominator. So 5 and 8 could be changed to the common denominator. One easy way to find it is to just multiply them together. So 5 times 8 is 40. So I'll multiply this one by 8 and this one by 5. And do the same to the top. So that means we have 16 over 40 plus 15 over 40. Now we can go ahead and add because the denominators are the same. So that gives me 31 over 40, which is in lowest terms. Now, you don't have to multiply the denominators together to get the common. Remember we want the lowest common. Now, you can multiply them together. So I could make the denominator 7 times 14, which is what? 7 4 is 28, 7 1, so 98. And then reduce at the end. So you can do that. But the lowest common denominator sometimes is smaller than that. So I know that 7, I can change 7 to 14. So if I multiply this by 2, then I get 8 over 14. So I don't need to go any bigger than 14. I can. I could do 28. I could do 98 by multiplying them together. But I'm going to do the smallest. So 8 minus 3 is 5. And that way I don't have to reduce at the end. So it's up to you. You can make it bigger than 14, or you can just go with the lowest common. So here the lowest common denominator between 5 and 3 would be 15. All right, so I multiply this by 3 to get 15, this by 5 to get 15. So that gives me 12 over 15 plus 10 over 15 is 22 over 15. You can leave that as an improper, or you can change it to a mixed. So 15 goes into 22 once, and there would be 7 left over. So either one's fine as long as the improper is reduced. In this one, I want to change to an improper fraction. So 5 times 2 is 10, plus 2 is 11. 3 times 1 is 3, plus 2 is 5. And then I'll change to common denominator of 15. So multiply this by 3 and this by 5. So that's 33 over 15 minus 25 over 15. And that leaves me with 8 over 15. And that is in lowest terms, so we can leave that answer.